Good afternoon. Let's go over guided notes 2.6. Sorry I didn't get this out there sooner to you. I thought I'd already completed these. So we're going to start with rational exponents. A rational exponent indicates a power in the numerator. So that would be the m in this case, and a root in the denominator. So I always usually think of this as a to the power over root. In fact, anytime I'm solving things, that's how I talk through it with myself. I don't say a to the m over n. I say, x or a to the power over root. I always think power over root. And I know that if you had 550 before this class, you didn't spend a lot of time in exponents. So I want to give you some tools we can use to solve these problems. But you also have your calculators to where it should make sense. But I say that, but I have people who are still struggling with understanding that raising a rational, like a square root to a square, is actually getting rid of it, because that's the same thing as a square is the power and the square root is the root. So that would be a to the 2 over 2, which is just an a. So they cancel each other out. So a to the m over n, power over root, is the same thing as the root of a raised to the power, or, and the opposite, it's the power first and then the root, which is how this is phrased as well. I tend to like to go with finding the root first and getting the number smaller and then going to the power, because to me it's a lot easier to do it that way. But you can just as well use your calculator in the one I'm about to show you. So if you're going to put this in the calculator, I'm going to show you that first, because that's what most of you probably want to know. And that's just taking your calculator and entering 8. And now some of you have an upshift, or some people call it a caret. I don't know. You need to open parentheses, usually, sometimes you don't. 2 divided by 3, close parentheses, and equals. And that will give you what 8 to the 2/3 is. All right, now doing it the other way, like I just said, I like to take the root first and then raise it to the power. So I'm going to choose to do that one. Pardon me. So the cube root of 8 is just 2, and then 2 squared is 4. That's it. So if you did this, you should have gotten 4 for your answer. If you do not, and you struggle with this, please let me know. As you're going through this, please write to the side if you have any questions. And that way, when we meet, you can just go back through your notes and say, okay, I had a question on this. Let's go over that. All right, let's go to the next one. Example 2 is solve the equation, including a variable raised to a rational exponent. So solve the equation in which the variable is raised to, okay. So x to the 5/4 is equal to 32. Now, what I told you a while ago is if you have an a or x to the power of a root, then they cancel each other out if they're the same. Well, the same thing goes for here. We can just take this and raise it to the reciprocal of 4/5. But what we do to one side, we have to do to the other. Let me show you what that does over here with the fractional part. When you have a base with an exponent raised to another exponent, those two exponents get multiplied. This was covered back in the prerequisite portion of the book. So if you're multiplying those two exponents, that's just 5/4 times 4/5, which is equal to 1. Okay, that's our goal, is to get rid of this when we're trying to solve for x. All right. So x will equal, well, this is the same thing as power over root. So the power is 4 and the root is 5. So this is just the 5th root of 32 raised to the 4th power. Or you could say 32 to the 4th power, or the 5th root of that. Either way, your call. So x equals, the 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So that is 2. Raise that to the 4th power, 2, 4, 4, 8, 8, 16. So the answer is 16. X equals 16. Okay. Next one. Again, if you have any questions, please write it down. Example 3. Solving an equation involving rational exponents and factoring. So solve 3x to the 3/4 is equal to x to the 1/2. So they want us to in factoring. All right, so I'm going to take the 3x to the 3/4 equals x to the 1/2. I'm going to bring that 1/2 to the other side since we're going to do factoring. So minus x to the 1/2 minus x to the 1/2. So I get 3x to the 3/4 minus x to the 1/2. Now, one of the things I need you to understand is we need these denominators to look alike. We could pull out 1/2, but we need it to look a little differently because I'm just trying to make it look a little more simple for you. So what you need to understand is 1/2. If I take 1/2, I can multiply that by 2/2, 3/3, 4/4. It doesn't matter. In this case, I'm going to choose 2/2 because I want my denominator to be 4 as my 3/4 is. So I'm going to end up with 3x to the 3/4 minus x to the 2/4 is equal to 0. Now it's going to be easier to see that we can factor out x to the 2/4. And we're left with the first term as 3x to the 1/4 minus 1. And that's equal to 0. Okay. Once you have it in this format, we take the first term, x to the 2/4, and set it equal to 0, and we'll solve for that. Well, that's just, we're going to do the same thing we did before, raise it to the 4/2. Now, I immediately saw that it's x equals 0. Taking 0 to the 4/2 or whatever you want to do is just 0. I didn't have to do that because I just automatically saw that it's going to be 0. But the next one, and if you didn't see that, I'm sorry. I'm not making fun of anyone. It's just over time you can see things like that. So 3x to the 1/4 minus 1 is equal to 0 as well. Let's solve for that. So we're going to add 1 to both sides. And we get 3x to the 1/4 is equal to 1. Divide both sides by 3. And x to 1/4 is equal to 1/3. Ooh, this is nice. You need more paper for this one. So what we're going to do for this one, since this is power over root, this is the 4th root, we're going to actually, we can just take these to the 4th, to the 4/1. So x equals 1 to the 4th is 1, 3 to the 4th, 3 times 3 is 9, so this is 81. Okay. All right, let's go to example 4. Any of that you didn't understand, please get with me. So 5x to the 4th is equal to 80x squared, and they want us to do this by factoring. So 5x to the 4th equals 80x squared. I'm just going to move the 80x squared to the other side. And I get 5x to the 4th minus 80x squared is equal to 0. Well, what do they have in common that I could factor out? 5 goes into both of the numbers, the 5 and the 80. And that leaves me with a 1 and what is that? 20? 16. And we could also factor out an x squared. And that would give us an x squared here and nothing there. And set each of these equal to 0 and solve. Divide both sides by 5. X squared equals 0. So this is just going to be x equals 0. For this one, now they've been wanting us to factor. There's 2 ways you can handle this, that I'm see automatically I would handle it. One of 2 ways. One is factor these into 2 parentheses because it's the difference of 2 squares. So x minus 4 and x plus 4. Set those both equal to 0. And solve for x. The other way to do this, and it's fine if you do it that way or if you do it a different way. The other way I saw whenever I look at this is Well, I can move the 16 to the other side. And I get x squared is equal to 16, take the square root of both sides since we're solving for x, and the opposite of square is square root. So x is equal to plus or minus 4. Okay, got the same answer. Either way, however you want to do it, totally cool with me. Alrighty. Number 5. Solve the polynomial by grouping. Okay, given 4 terms in your polynomial equal to 0, we can just take this. I'm going to just rewrite it real quick. And I only look at the first 2 terms. What do they have in common that I can factor out? Okay, and I can factor out an x squared. And I'm left with x plus 1. All right, then I look at the next 2 terms. What can I factor out? -9. And I'm left with x plus 1. Okay, it's at this point I look at this term and this term and see what they have in common that I can factor out. I can factor out x plus 1. When I pull x plus 1 from this term, I'm left with x squared. And when I factor out x plus 1 from this term, I'm left with -9. Okay, let's set each of these equal to 0 and solve. The second one can be solved just like the last one in 2 different steps. I'm just going to do it by factoring this time. So x is equal to -1, and this breaks down into 2 parentheses, x plus 3 and x minus 3, difference of 2 squares. Set them equal to 0. So our answers are x is equal to -3, -1, and 3. Okay. Let's see here. It says radical equations, an equation containing terms with a variable in the radicand is also called a radical equation. So let's solve an equation with one radical. Solve square root of 15 minus 2x is equal to x. Anytime I see this, and first of all, I'm delighted because it's pretty easy to get rid of the radical in this case. So I just take that and I'm going to just square. The opposite of a square root is squaring, and that just cancels it out. But what you do to one side, you have to do to the other. That's why this equal sign is here. All right, so I end up with 15 minus 2x is equal to x squared. All right, I want to get all my terms on one side and set this equation equal to 0 because I'm going to end up factoring it into 2 parentheses. So I'm going to subtract 15 from both sides, and I'm going to add 2x to both sides just to get it moved over. And I get 0 is equal to x squared plus 2x minus 15. Just notice that I put them in order for the polynomials from the highest exponent, the highest degree to the lowest. So I'm just now going to break this into 2 parentheses. When I'm breaking them into 2 parentheses, with the x squared, it's the easy one. It's just x and x, right? X times x is x squared. But for the second terms, for each of these, I have to look for my -15. And -15 breaks down into 15 times 1 or 5 times 3. Okay. It's at this point, I look at the middle term of my trinomial, and it's a +2. Well, I have to see, okay, if I can add or subtract these 2 numbers and get a 2, then that's my mix. It cannot. It's either going to give me 16 or 14. Then I look at the next one, 5 and 3. Yes, they can. So 5 and 3 will give me 2. They have to be subtracted. There's the next thing. Who gets the positive and who gets the negative in this case? Because there's a negative in this trinomial, so there has to be a negative somewhere. Well, being that the middle number, the middle term is a positive, you want your largest term from down here in your, if you think of it in FOIL, you want these 2 checked out, the outers and the inners. So I go, okay, my outer is 3x and my inner is 5x. I need my 5x to be positive. So this is going to be positive in order to give me a positive 5x. And this will be my negative so that it can subtract and get a 2x for an answer. All right. And then the last thing I do here is I set these each equal to 0 and solve. So x plus 5 equal to 0, x minus 3 equal to 0. I get x is equal to -5 and x is equal to 3. And that is my answers. Ooh, or is it? So let's check this. There's there's 3 different things you're going to need to worry about where you really should check. Okay. I'm not going to say have to because no, you probably have to. You have to check to make sure that both of these numbers work. All right. So let's check. One of the ways is if you have a fraction with a variable in the denominator. Another way is if you have a square root. And the third way is if you have an absolute value sign. Okay. So I'm going to check by putting, let's see if I've got any clear paper. Yes, I do. I'm going to take the -5 and plug it in where my x's are. Oh, I can see that problem already. Okay. I'm just going to keep going though. Five does not equal -5. What I saw immediately was you have a radical that's equal to a negative number. That's you're not going to get a radical that's going to provide you a negative number in this manner, not a square root. Okay. And it came out that 5 equals -5, which it does not. So -5 doesn't work. Now we need to check 3. So 15 minus 2 times 3 is equal to 3. All right. So that's just the square root of 15 minus 6. That's the square root of 9 equal 3, and that's 3 equals 3. Perfect. So 3 does work. So our answer for example 6 is x equals 3. Okay. All right, let's move to number 7. Solving a radical equation containing 2 radicals. All right, so with the one earlier, I just squared the radical and squared on one side and squared the constant on the other. We can't do that in this case. Well, I'm sorry, we can do that in this case, but you can't just square each of the terms. That is incorrect. It's not keeping each of the terms equal. It's keeping each side of the equation equal because there's an equal sign here. So this side will have to be squared and this side will have to be squared. Well, I don't want to square 2 radicals using FOIL. That doesn't sound fun to me. So what I'm going to do instead is I'm going to move one of these over to the other side. So when I FOIL that, it's going to be a lot prettier. All right, so I'm going to just subtract the square root of x minus 2 from both sides. I could have done either one. I just chose this one. And I'm left with the square root of 2x plus 3 is equal to 4 minus the square root of x minus 2. All right, I think this is a long one. Now, in order to get rid of the radical on the left, I'm just going to square it. What you do to one side, you have to do to the other. So you square the entire right side, not squaring 4 and then squaring square root of x minus 2. That would be delightful, but it's wrong. Okay, this square root and this square cancel each other out, and I'm left with 2x plus 3 equals. All right, here's where I'm going to use FOIL. Or I could square the first, multiply them together, and double it and square the last, which is my preference. But I'm going to FOIL it because I think that's how most of you feel more comfortable. So I'm going to write 4 minus the square root of x minus 2 times 4 minus the square root of x minus 2. All right. FOIL is just, let me write F-O-I-L. The first 2 terms, so 4 times 4 is 16. The outer 2 terms, so 4 and negative square root of x minus 2. The inner is minus 4 square root of x minus 2. And then the last 2 terms are negative times the negatives are positive, and that is just the square root of x minus 2 squared. Just keep bringing down that left side. All right, keep bringing down the left side, 2x plus 3. Combining like terms on the right. I get 16 minus 8 square root of x minus 2. I can do that because these are exactly the same. And then the last is plus, well, the square root and the square cancel each other out, so it's just x minus 2. Continue combining like terms. 16 minus 2 is 14. And what else? I think that's all we can do there. I'm going to grab another sheet of paper to continue this. Otherwise, it's going to get a little too tight. All right. Actually, I can do one more line. I want to bring this 14 and this x over to the other side. So I'm going to subtract 14 and subtract x from this side, and then put negative 14 and negative x over here. So I get x minus 11 is equal to negative 8, the square root of x minus 2. All right. Well, in order to get rid, I mean, I could go through and divide by negative 8, but I don't want to. Because it doesn't do me any good. So I'm just going to square this side to get rid of this radical. And when I do that, I get negative 8 squared is just 64. And then this x squared of x minus 2 squared is just x minus 2. And that's equal to x minus 11. Okay. Now I'm just going to, I'm just going to distribute the 64 over the binomial, and I get x minus 11 is equal to 64x minus, what is this, 128. Okay. Let's solve for x. That's what we have left. So I'm going to bring the 11 over here and the 64x on the other side. Minus 64x minus 64x plus 11 plus 11. So I get negative 63x. Oof, losing y'all. Negative 63x is equal to, well, that's going to be a 7. So 117. Yeah. Divide both sides by negative 63. And I get x is equal to what? 3, what's going to give us a 7? 117 divided by 3. 39. And it's positive because a negative divided by a negative is a positive. All right. We need to check this one. Well, it starts with a square root. Let's go back up here and look at the original problem. So I got x equals 39 for the entire answer. So if I plugged in 39 for x and 39 for x, I would get 2 times 39 plus 3. So I don't have to worry about that being a negative. So that's not going to be an issue. Here. And then the other one, 39 minus 2, well, that's not going to give us a negative either. So that's a non-issue. So that's all I really need to do to check that. It's not going to give me a negative under my radicals. So it shouldn't be an issue. All right. Absolute value equations. Please make sure that you have access to this information in your notes when you're doing your test or your homework or whatever you're doing. Okay. So if the absolute value of x is written in this manner, to where there's 2 parallel lines on either side of the term, it has the following properties. If x is greater than or equal to 0, then the absolute value of x is x. If x is less than 0, so it's negative, then the absolute value of x is a negative x. So the following properties are used for the absolute value equation. If we have a constant, so you're going to have the absolute value of your terms, ax plus b, and you have that set equal to a constant. If that constant is a negative, this is a D&E, does not exist. There's no such a solution to where the absolute value is negative, because the absolute value, all it's representing is the distance from 0 to a number. Okay, so it's like you're measuring. That's all you're doing. So if you get a negative number from absolute value, that's ridiculous and it has no solution. So if you're doing my math, it's a D&E. Okay. For C equals 0. So if you have an absolute value of your terms, binomial or whatever, and it's set equal to 0, you're going to get one solution. And all you have to do is take that setup, set it for 0, and just solve it, ignoring the absolute values. Okay. And then the last one is if the C, the constant, is greater than 0. So it's positive, it's anything greater than 0. Okay. There will be two solutions. So you'll have to take these and set them up for a positive and a negative C. So you would take your AX plus B equal to C and AX plus B equal to negative C and solve for both of those. And I'll show you how to do that here in just a moment. This tells you how to solve it. If C is greater than 0, you're just going to set them up to C and negative C. I didn't realize that was there. All right, so let's go to example 8 and work through these. Let's get some more space. There we go. I need more paper. So the first one is set up 6x plus 4 equal to 8. Okay, well, that C is greater than 0. That 8 is greater than 0. So we have to set these both up as 6x plus 4 equal to 8 and 6x plus 4 equal to negative 8 and solve for x in both cases. All right, we're going to have two solutions here. So I'm going to subtract 4 from both sides. 6x is equal to 4. So divide both sides by 6. And x was equal to 4/6. Or you're going to need to reduce. X is equal to 2/3. Okay. The next one is subtract 4 from both sides. We get 6x is equal to negative 12. Divide both sides by 6. And x is equal to negative 2. Okay. There's our two answers. All right, the next one is 3x plus 4 is equal to negative 9. I just said, if you have an absolute value, it cannot equal a negative number. This is a D&E. Does not exist. There's no solution. There's no way that absolute value is going to provide us with a negative number. So let's go to the next one. C is 3x minus 5. Minus 4 is equal to 6. Okay, well, we need to have this solved for our absolute value. Okay, so I'm going to add 4 to both sides. All right. Because this is greater than 0, it's positive. We have to set this up to 3x minus 5 is equal to 10, and 3x minus 5 is equal to negative 10. Add 5 to both sides. Divide both sides by 3. Do the same thing on the other. Solve for x. And x is equal to negative 5/3. So x is equal to 5. Oh, and x is equal to 5/3. Hard to do when you're not exactly looking at it. All right. As you're going through, please make sure that when not just taking notes, write down over on the side or on a separate sheet of paper referencing this so you know, okay, what questions do you have for me? What can I do to help clarify this? This is how you should handle all these notes. All right, and then the last one here is negative 5x plus 10. Well, this is set equal to 0, so this is going to have just one solution. And because it's just one solution, all I need to do is, I can do it on this here, is take the negative 5x plus 10 equal to 0 and just solve for x. That's all I have to do. So subtract 10 from both sides. Negative 5x is equal to negative 10. Divide both sides by negative 5. And x is equal to 2. There's your one solution. Okay, and that was example 8. Let's move to example 9. All righty, solving a fourth degree equation in quadratic form. Solve this fourth degree equation. 3x to the fourth minus 2x squared minus 1 is equal to 0. First thing I see that I want to do is make this look a little prettier. I don't want to deal with any fourth powers right now. So I'm going to let A equal x squared. And now, I had a wonderful conversation with a student after class the other day, and he was under the impression that we are factoring out. I think this is the concept. I think he thought we were factoring out the x squared and it would need to be in every one of these terms. That is not the case. We're just getting rid of having to deal with an x to the fourth in our factoring and make it something that most of you are used to looking at, which is going to be a square. I'll show you how that looks. So when we substitute a, the letter a, for variable a, for x squared, we're going to get 3a squared minus 2a minus 1 is equal to 0. This looks more like something that you're used to. So we can just factor this sucker into 2 parentheses. We're going to have 3a and a, because multiplied together we get 3a squared. We're going to have 1 and 1. There's not a lot we can do with that. So the next thing is we just need to check our OI, the middle 2 terms of our FOIL. So outer and inner. Outer terms are 3a, inner terms are 1a. We need it to be a negative in the middle term. So that means that we're going to have negative for this one. So negative here, positive here. Set each of these equal to 0 and solve. 3a plus 1 equals 0, and a minus 1 equal to 0. This is a equal 1. Subtract 1 from both sides. You get 3a is equal to negative 1. Divide both sides by 3. A is equal to negative 1/3 and 1. Oh, we're not right. That's not right. You know what we could do here? Actually, it is right. So I stopped before whenever I was up here in class, and I went ahead and substituted back my x squared here. I don't have to do that. I mean, I could. What I did was fine. I can also do it here. So I'm going to get the same answer. So what I did in class is great, but I just went through this whole problem and I forgot to substitute x squared. It's okay because I can do it now. So where the a is, I'm going to take x squared is equal to negative 1/3, and x squared is equal to 1. That's the same thing. So if I take the square, because I have a square, I want to get rid of it and solve for x, take the square root of this side and the square root of the other. But remember, when you do that, you're going to get plus or minus 1. Okay. So we're going to do the same thing over here. We're going to take the square root of both sides. When we do that, we're going to get plus or minus for our answer. All right. But when I take the square root here, this is going to look a little wonky. What is the square root of negative 1? Well, this is equal to plus or minus. Let me put this in your notes. The square root of negative 1 is equal to I, which represents imaginary number. Okay. So it's plus or minus I divided by the square root of 3. We're still not done because you're not supposed to leave a radical in your denominator. You have to rationalize your denominator to where there's no radicals. So that square root has to come out. So let's come over here and do that real quick. We have plus or minus I divided by the square root of 3. Well, to rationalize, you just multiply by the square root of 3 over the square root of 3. And my answer then is plus or minus I square root of 3 over, well, square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is just 3. So x equals plus or minus I, the square root of 3 over 3, and x equals plus or minus 1. Those are your answers. You also know, because based on the degree, how many answers you're going to end up with. Because there's a 4 here, you're going to end up with 4 answers from this problem, okay? Even though 2 of them are imaginary. All right, let's go to the next one. Solve an equation in quadratic form containing a binomial. Do the same stinking thing I did in the last one. I don't want to factor the x plus 2, so I'm just going to let a equal x plus 2. All right, so then I have a squared plus 11a minus 12 is equal to 0. All right. Boop, 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 boop. We'll get a and a. Well, what are my factors of 12? 12 and 1, 4 and 3, 6 and 2. Which of those together will give me an 11? 8, 7, here we go. 12 and 1. Because my middle term is positive and I have a negative here, I need to have a positive for my largest term and a negative for my other. Set each of these equal to 0. Or at that point, you can substitute back your x plus 2, but we'll do that here in a second. Let's just go ahead and finish this out. A is equal to negative 12, and A is equal to 1. So now I'm going to put x plus 2 is equal to negative 12, and x plus 2 is equal to 1, and solve for my x's. Minus 2, x is equal to negative 14, minus 2, x is equal to negative 1. There are my two terms. Okay. Any questions, let me know. Okay. It's done. Last one. This is the one I did today in class because I totally missed it in class the other day. But I just want to make sure that you have this. All right, so we've got negative 4x over x minus 1 plus 4 divided by x plus 1 is equal to negative 8 divided by x squared minus 1. First thing I see that I need to do is I need to factor this difference of two squares, x and x minus 1 plus 1, because I need to make sure that as I'm multiplying through and getting rid of my fractions here, I've taken care of ensuring that I have all of the factors that are making up the denominator. Okay. So what I'm going to be multiplying everything through by is x minus 1, x plus 1. And I'm going to do this a little bit different than I did in class as well. I'm going to put them side by side so you can see how this is going again. So that's just negative 4x over x minus 1 times x minus 1, x plus 1. And then plus 4 over x plus 1 times x minus 1, x plus 1 is equal to negative 8 over x minus 1, x plus 1 times x minus 1, x plus 1. All right, I know this parenthesis looks a little weird, so sorry about that. X minus 1s are gone, and we're left with negative 4x, x plus 1. X plus 1s are gone, so we're left with plus 4, x minus 1. And then over here, x minus 1s are gone and x plus 1s are gone, and we're left with negative 8. All right, we need to distribute through this binomial, and we get negative 4x squared minus 4x. Distribute over the binomial, we get 4x positive minus 4 is equal to negative 8. I'm going to bring the 8 over and combine my like terms here. These are gone. Actually, I don't even have to do that. So I get negative 4x squared minus 4 is equal to negative 8. Yeah, I can take the 4 to the other side. Let's add 4 to both sides. Or you could factor. You could bring the 8 over and factor it. It doesn't matter either way. And I get negative 4x squared is equal to negative 4. Divide by both sides by negative 4. And I'm left with x squared is equal to 1. Take the square root of both sides, and I get x is equal to plus or minus 1. Okay, so now what? Well, we have variables in our denominator of this problem. You gotta check. If you've got variables in the denominator, that's one of the main times you've got to check your work. To not check your work, but check to see if it actually truly works. All right, so what I'm going to do first is I'm going to rewrite these down here so I can see them. Negative 4x over x minus 1 plus 4 over x plus 1 is equal to negative 8 over x squared minus 1. All right. So the thing with the fractions is you can't have 0 in your denominator because that's undefined. So if either of these terms will provide us with a 0 in our denominator, then there's no solution here. Okay. So the first one I'm going to check is positive 1. I can see that if I put a positive 1 in this portion here, I'm going to get a 0. So positive 1 is not going to be a part of the solution. The next number is negative 1. So I'm going to check negative 1. It works for this one. I get negative 2. But over here, negative 1 plus 1 is going to give me a 0. So again, -1 is not working either. There is no solution to this problem. Okay. All right. That is it. All right. I'm going to make 2.7 for you and get this out. That wasn't too bad. Let me know if you have any questions.